So, first, would you say and spell your first and last name and your title as it relates to this project?
My name is Joshua Willms, Joshua Willms, and it's really that.
Okay. And your title?
I'm a MD PhD student at Texas Tech University Health Science Center.
Okay. And how, take a small step up for me. Good?
Yeah.
I like the painting.
Oh, yeah.
Okay, so, how did you know him? And did you work with him in school, or did you know him at a personal level?
I didn't know Chris for very long, but we were both officers in the Scholar Service Organization for TTU HHMI, and we both had our honors thesis class together. So that's just a once-a-week meeting with all the honors students who are doing an honors thesis, and so I met him there, but I didn't know him for particularly long before the accident.
So then, why did you feel called to complete his research?
I feel like a lot of times people only want to do nice things for like their family or for their closest friends, but I think the world would be a much better place if people would go to great lengths to help people that were just, you wanted to help them because they're people. And then also for me, like the group of TTU HHMI was really, really important to me. I didn't get in the first time I applied, and then the second time I applied, I got in, and it was at a time when I was going through some really hard things. And so like the acceptance into a new group, and it's like a really tight-knit group, was really, really important to me. It was really, really important. So there was the aspect of, like our motto is once a scholar, always a scholar. It's of acceptance, like everybody is a family in our group. So in a sense, like everybody that was in the group, I considered to be my family. And then at the memorial service, I saw Grace's family, and at the service, I was thinking like, the service is good, but once this is over, what happens to his memory? It would slowly fade away, and people would forget. And I didn't want that to happen. And so sort of a science-y way to go about fighting that is to try to finish the publication he was working on, because then like you preserve a small part of the person, because you have some of their ideas, you have some of the work that they did, the thoughts they were thinking, and then if it's published or like presented at a conference, then it's a concrete part of Chris that would be preserved. And then like primarily for me, I wanted to do something to help his family heal, and I thought that preserving a piece of his memories and thoughts and actions for them would then help them heal.
That's beautiful. Why something that sort of, I imagine you had your own research going on and classes, and
yeah.
How busy were you, and what did you have to do to make the time to finish it?
Yeah, I was extremely busy. I was also doing some marine biology research. That was my primary lab, and that was my start in research. So I love that. And my mentor, Dr. Diamond, is one of the most amazing people in the world. So when I had the idea to like pick up possibly doing 2 labs at the same time, like at first it was, this is a bad idea, there's not time for this, and also with Dr. Schwilk, it was and also Dr. Schwilk is one of the most amazing scientists and best mentors in the world, and then just from a practicality standpoint, like where will time to do this. And so, and there may not have been time to invest to finish it, but I ended up taking another year for multiple reasons, but this project being one of them in my undergrad, to be able to invest enough to finish the project. That wasn't the only reason I spent another year at Tech, for Victory Lap. But that extra time helped. Yeah.
So what did you do with the research? I guess first tell me what all you did to finish it, and then where did you publish it?
Yeah. So it's not published yet, but we're very close. So it started out with I joined the Schulk lab, and I started learning the ropes. I learned from a graduate student. I learned from Dr. Schwilk how to do the project. And then after, I'm pretty bad with time periods, but after a certain period of time, the baton was basically passed to Taylor Brown, who is another TTU HHMI scholar, so now Sizer scholar. And then she did the majority of the work. So I sort of started out, and there was much to be done. We did many trips to the mountains. We went to the Davis Mountains, the Chizos, and the Guadalupe Mountains. And I could tell you stories from all of those trips. We went to every place multiple times. And those were extremely enjoyable for me because I grew up in the mountains in Los Alamos, New Mexico. And living here in Lubbock for so long, I've sort of missed, differences in elevation. So it was really, really fun to go there. When we actually collected the data for this project, we would go and you get up before dawn, because if the sun is up, then the trees start to do photosynthesis and it messes with our results. So you have to get up before the sun, and you get a 2-gallon bag of water, not water, but plant blood, which is a fancy way of saying like water with some KCl. And you have to go find a tree with a GPS, like a specific tree of a specific species, and then you'll bend the twig down under the water, because if you cut it and it's out of the water, then there's actually a negative tension inside of trees. That's how they move water. So we have vessels, and we have to distribute nutrients and basically keep all of our tissues alive. And plants have to do that too, because they're big. They have to have vessels that transport things. So they transport basically water, and they have to go up a huge distance to get from the roots up to the leaves. And so basically pulling that water up creates a bunch of negative pressure. You can't have a negative pressure with gas, because you just get to zero and that's it. But with water, since it's basically polar, so it kind of sticks to itself, you can get to extremely negative pressures. So if you cut the twig and it's not underwater, then the water that's in those vessels gets catapulted, and it pulls. And you wouldn't know it from just chopping a branch off of a tree, but the twig definitely knows it. So you have to bend the twig down, get it underwater. You're reaching up, getting a branch and bending it down underwater, and then you have to cut it underwater. So you'll invariably end up taking a shower out in the middle of nowhere at 5 a.m. in the cold. But I grew up in Boy Scouts, so to me that was oh, this is fun, Sort of the craziness of it is what makes it fun. So we went on multiple trips to the Davis Mountains to we would collect those twigs, and then we'd bring those back to the lab, all keeping them underwater the entire time, keeping them in plant blood. And then once we got back to the lab, we only had maybe a week to 2 weeks to find out all the information we wanted to find out about them. So what we would do is we would get about a 13 centimeter section of a stem, and then we would basically hook it up to a hydraulic system, and then we would see how fast, we would see basically how much water goes through the stem to be able to, so we'd start out normal conditions, it's a healthy plant, and there's nothing wrong with the stem, and then water goes through, and that's a measure of basically, how, how well the plant is doing. And then we would take the stems, and we would simulate drought. So that's what we were trying to study was how do these different species respond to water shortage. Instead of we couldn't just dehydrate them. So what we did is we put them in a centrifuge, and we had little wells so they could stay underwater the entire time they were in a centrifuge, and then we would spin them up to sometimes 10,000 rotations per minute, which is super, super high, and that tension would basically mimic a water deficiency. And then what happens, if the tree isn't getting enough water, that negative pressure that I was talking about earlier, the water can actually boil. So the temperature isn't high, but you don't have to have high temperature for the water to boil. You can also have a really low pressure. So the water will, you'll basically get an embolism or a bubble. If we get a embolism, that can be really bad for us, you're blocking the blood. Same thing for a plant. If you block their vasculature, then you can't transport water anymore. So the drought equals low pressure equals you start getting bubbles because the water is boiling, and then once you have one little bubble, it makes it easier for more bubbles to form around it, and you'll get if this is a cross section of a stem, and you've got one little bubble here, you'll start getting more and more bubbles around it until a certain percentage of that stem can't get water through it. And then there's a point of no return, and we want to define what that point of no return is, where the tree basically has to sacrifice the stem. So we would, we'd go collect the stems, 5 a.m., chop them, bring them back to the lab, see how much water was flowing through them, and then simulate drought and figure out how much drought can they actually handle before they start to die.
And so where are you going to publish it, and what is it going to be called?
Yeah, what's the title? Drought response of oak resprouts and I don't know, I'm making this up. This is something they could call.
They haven't named it yet.
It has a name. The baton has been passed for some time, so.
Well, that's my next question.
Yeah.
Since you said basically you didn't know him that well, but once a
scholar, always a
scholar.
scholar.
So you said everyone's a family.
Yeah.
But you don't know this guy, and
well,
now you're passing on the baton to somebody who is also not your family. So it's a bunch of people that really don't seem to have known each other at first.
Yeah.
All working on one thing, and you said do things for strangers. Do you think Texas Tech is a family?
Yeah, I feel like Texas Tech is absolutely a family. I've been here for 6 years, and I'm doing my MD PhD here, so I'll be here for 8 more years. So yeah, I feel that way. But then in particular, the TTU HHMI organization and now Sizer, that pocket to me in particular is my closest family. So the people there, I would put a particular emphasis.
What does it mean for you to be able to finish this research for one of your family members?
For me, It was getting to do something to help his family heal, and then to help the scholars in our organization, like Saba, who knew him well, to help them heal. So that's what it was for me.
Is there anything else that you would like to add?
Let's see. I know Taylor can't be here, but I don't think enough can be said about how much she invested in the project, and it would have been impossible without her. And so she's the undergraduate who's carrying it to an end, and then also can't say enough about Dr. Schwilk, how good of a mentor he is, how he facilitated everything that went on, and he mentored us. And then also, I want to tell you a little bit about my vision for the project was to make it very inclusive, to where all of the scholars could have a piece if they wanted, and that's sort of how I originally saw it going, because I didn't think there would be enough time. But then Dr. Schwilk said, you need to have one person dedicated to it to take initiative and sort of organize things. And almost all of the scholars got to participate. So they would come to the lab, and we would train them on how to use the hydraulics, or how to use the centrifuge, or it might have just been doing some data recording, whatever it was. We wanted everybody to be able to participate. So almost everybody did. And then we also had a field trip to the Davis Mountains. So I think we had 4 or 5 scholars got to come see the mountains where Chris did work, got to hike. We had a little bit of a data. And so everybody also got to participate there.
If Chris could be here today and see what all you have, not you, but your team has done for him, what would he say?
I don't know.
Do you think he'd be proud?
Yeah. I would just think that I'm really close to my brother, and if something happened to me, probably the dominant emotion for me would be I'm sorry that my brother has to go through that. So I spoke to Chris's brother once, and so for him, I don't know. I try to put myself in that position, and if I was so invested in a project and I wasn't able to complete it, I would be very grateful that a little piece of me was preserved, and that something was being done to help my family.